The main thing that we are going to look at today, well, a few different things, but one of the main things that we are going to look at is how we can describe or explain the shape of these graphs that we're going to look at, and then how we can talk about finding the mean and the median for these. So specifically a mean and median on these histograms, okay? And it's, I don't know, some people think it's really easy. It kind of visually they can see it. For others, they struggle with it a little bit. So we will practice with it quite a bit. Okay, so if we are comparing, if we are looking at a set of data, we need to be able to talk about, to describe it, we need to talk about the center. And so we'll have to decide based on the data whether we should use the mean or the median, and we'll talk about that. And then to describe, we also want to be able to describe the spread. So we want to talk about the center and then the spread. So to describe the spread, we're either going to use the standard deviation or the 5-number summary and or the IQR. Median, we're looking for the middle. There's another term I'm going to give you to help you think about this. And then for the mean, we're going to look for the average. Now that's if we're actually given the data. We want to be able to look at these histograms, and we're going to talk about the shape of them in just a second. But then we also need to talk about how we can find or kind of show a representation of where the median and the mean are on these graphs, okay? All right, so besides median being middle, the other thing that I want you to remember here, another way of thinking about it when we are looking at a histogram and we have to find where this median is, I want you to think equal areas point. Equal areas point. And I'll explain what that means in just a second, a little bit more. When we are looking for the average, another way of thinking about this, if we are looking or visually considering a histogram or other graphs, we are looking for the balance point. Okay, so those are terms you're going to kind of want to equate or connect with each of those particular terms, okay? So equal areas point and then the balance point. Okay, so first thing to realize is that when we are looking at a set of data, if we're looking at a graph or a set of data, in our mind, like what you guys have done previously in math classes when we've talked about something being symmetric, it has been exactly perfectly symmetric mirror image. And what I need you to realize is that we are looking at real life data, and in real life, things are not going to be quite that perfect. So you're going to see, you might see some graphs that are truly nicely, perfectly symmetric. If that's supposedly real life data, you may want to actually kind of question it a little bit. Now, there are definitely some certain types of data. Where are my psych students?
I was a psych. Oh, yeah.
Okay.
We're retired.
Did you guys talk about normal distributions, probably?
I don't recall.
Like IQs, taking tests, IQ scores, that type of thing. It tends to show a rough, like a bell curve, a bell-shaped curve. So those are, that is what's referred to as a normal distribution, and it is symmetric. So we're using kind of that model or that bell-shaped curve to kind of represent this data. But like I said, a lot of times in real life, it might not be quite that perfect, okay? Jake, there's 3 papers to pick up over there. All right, when we are talking about or looking at the shape of these curves, we're going to talk about shape, and we're going to talk about finding that mean and that median. So the tendency is you almost kind of, you have to think that it's opposite what it seems like it would be. So when I tell you that the shape of this particular histogram, it is skewed to the left. So when you look at or think about skew, you are looking at, to decide what the direction is, the direction in which the graph kind of trails off, that's the direction of the skew. So that is a graph that is skewed left. I would say that this middle graph is roughly symmetric. So keep in mind what I said. It is not It's not perfect. It is not completely perfectly symmetric on each side. But I would definitely say that would be considered roughly symmetric. And this last graph here in terms of the shape
Skewed right.
is, yes, exactly, Hunter, is skewed to the right.
So basically, whatever side is like
Lowest. That's what side you're gonna say. It's skewed.
Where the values tend to trail off, that is where the skew is. So, all right. So in terms of talking about the shape of these graphs, this is skewed to the left. This is roughly symmetric. This is skewed to the right. We can also kind of talk about, in each case, in some instances, you may be asked to talk about whether or not there are outliers. And we'll kind of take a look at that as well along the way. None of these really have any true outliers. The tendency, I think, for some people is to think outliers would mean where they're the most values, but it's not. An outlier is a value that is out, way far away from all of the other values. And so there is this gap here in this particular graph, but then there are multiple values out here. And so we could make a case for saying, because there's that break, we could possibly say they are outliers, but because there are multiple values out there, then probably not,
why is there
right?
Why is there 2 bars between each value on the bottom? Or like
Yeah, it's just kind of the spacing that they've chosen to do on there. I will tell you, in a lot of cases, they grab three things to pick up, guys, on the way in. A lot of times, I'm not real keen on how they write or draw and space and label on the x-axis, but I gotta go with what they've got, just in terms of finding good visuals for you guys. Okay? Guys. Okay. When we are looking at or considering finding the median and the mean, think about what I had shared. For the median, we want to look for the equal areas point. Okay, so I'm going to kind of explain this in 2 different ways. So the first way that I would explain this is I need you to think about back in pre-K, preschool type days when you were building towers of blocks, right? So you guys built long, tall towers, and then you knocked them over, right? You built them as tall as you could, and then you bam, and you watched how far they could fly, right?
Pretty accurate.
Okay, pretty accurate, I would say. All right, so one way of thinking about or considering finding the median for a set of data is I need you to visualize this particular histogram. Think of each of those bars as blocks that we have, okay? And what we want to do is grab, if we had all of those here, we want to grab these blocks and we want to kind of start to pile them up or tower them up from each end. We want to basically build 2 towers right next to each other in the middle, kind of more or less, so that we could find where it would be even, that then you could knock it down. So we're going to work from the outside towards the inside. We're stacking these. So you have to imagine taking this particular stack and moving it over to this particular stack, and taking that fuller stack and adding it and moving it over this direction. We've got quite a bit over here, so we're not going to be able to stack a whole lot that way. We're probably going to need to move from left to right and keep stacking this way, right? So that's kind of one way of thinking about or visualizing where you're going to find your median, okay, is for some people visualizing and picturing stacking or moving those blocks so that you can stack them up and find where that middle would be. So for some of you, that might help. For others of you, the other way that I would suggest that you do this, and I will tell you, guys, I always have to draw and redraw, so don't you dare draw in pen. You better have a pencil out because you're going to need to draw and then you're going to need to erase probably, okay? So the other way of thinking about this is that you want to basically draw a line. You kind of need to visualize or imagine this is to begin with. You want to draw a line where you think probably the equal areas would be on either side. Kind of visualize those blocks or those towers. So you want to draw a line, and then you basically just have to kind of look and watch. And in my case, I'm going to actually shade just to kind of help you with this. So visually think about the fact that if this is the equal areas point, then that means all of this that I am shading, so this block, and this block, and this block, and this block, and that one. So all of that, is that equal to the same amount of stuff that I'm shading over here?
Maybe.
Or am I off a little bit one way or the other? And the reason why you do this in pencil is because typically you're going to have to shift this. You're going to have to adjust. I think I probably need to move a little bit to the right, probably. Would you agree on that one? I think probably a little bit to the right. So let's start over. And you're doing that same process again until you can kind of find or see or visualize that middle equal areas point. So I'm thinking it probably needs to be over a little bit more. And then we need to just kind of visualize shading again. So is this area that I am shading the same amount as this here? What do you think? I'm sorry? Yeah. Well, and see, here's the thing. Christina just said, I think the blocks is easier. Here's the thing. In some instances, you can actually kind of see and almost count, right? If depending on the scale and depending on how many bars there are, you can actually almost count. And that can be nice, but you're not always going to have that luxury. So you have to kind of come up with another way of thinking about that. All right, I think that that's probably about right for our median. So we're going to go with this. So here's our median. Oops, I wanted to do that, and sorry, let me go back over this. So here's our median. So like I said, you definitely have to do this in pencil and then go back and know that you're going to have to erase. Are we about all here? Phones have not made it up there, guys, if you've come in late. So take care of your phones. I better leave this open. There might be. I know we're missing 3 for sure. All right, there's our median. To find our mean, we're always going to find our median first, and then we're going to use what we know about means or averages to help us figure out where our mean has to be, okay? For a set of data that's roughly symmetric, yes, you're going to need to make a note about this. For a set of data that's roughly symmetric, the mean and the median are going to be very close to each other, if not exact. So that makes it easier. When we have skew, the mean gets pulled towards that skew. Okay, so you're going to want to make a note about that. Mean gets pulled towards that skew. So because we are skewed to the left on this particular graph, that means our mean is going to be closer down towards that left-hand side also. Okay? So remember, for our mean, we are going to look at what I consider what's called, quote unquote, the balance point. So we have to kind of use both of these ideas in order to kind of help us figure out where we're going to draw in our mean also, okay? To talk about this in terms of the balance point, I need you to think about the fact that, think to your physics, right? If we have a fulcrum point, right? Oh my gosh. If we were to have a fulcrum point here and we were if we were considering this as weight, if this is on a platform of some kind and we have if we put a fulcrum point, if we were to put this right here in the middle, obviously that's not going to work, right? That is not going to balance the way I've got, if I had a fulcrum point right here. There's no way, there's too much weight on this side. So we know we've got to adjust and move that fulcrum point this way a little bit. We know that fulcrum point, because it is skewed to the left, we know the fulcrum point has to be less than the median, but it can't be this far over, can it? So we have to this is kind of a judgment call also. I cut you guys a little bit of slack on this, but like I said, we're going to practice with this a lot, so you're going to become a little bit better at this. So obviously our fulcrum point can't be there. It's got to be farther to the right from that particular point, but the balance point has to be to the left of where we've decided our median is. So I would say probably approximately about right there. So I'm going to actually draw.
No, why'd you change the fulcrum?
So that's where our mean would be. So we're going to use, did I put those symbols up there? Yes, I did. So we use an uppercase M to represent the median. We use a mu symbol, that's the lowercase mu, that's the lowercase Greek letter m, to represent the mean. Okay? All right. Roughly symmetric, we decided, was the shape on this one. So equal areas point, we're going to find the median first. I'm trying to color code here. So probably, most likely, what do you think? Is this going to be is that equal areas on either side? Let's shade and kind of look if I'm coloring or shading in all of this.
Why would shading
Is that the same amount
Shading.
as this? No?
I think it needs
Which
to
way
go
do I
that.
need to
I think it needs
shift?
to go that.
Or I mean, yeah, right.
Yeah.
All right, one of you saying left and one of you saying right, so gee.
It's gotta go left. Left.
Is that better or worse? Okay, that's worse, so we're not going right.
Oh, what?
The fulcrum point?
Is that?
You gotta go down the middle.
No.
I agree, Christina, and this is the reason why you draw this in pencil, because I've been dealing with this for longer than you guys have been alive. I've been trying this, and I still have to draw and erase and redraw. So yeah, pencil. I think we were good right where we were to start. And that's going to happen sometimes. So we're going with that. All right, so that's our median. We tried farther right, and it didn't look correct.
But that's not right either.
What was the best?
Equal areas on either side.
But those three are all two.
All right,
One has,
so
Couldn't be right.
one has 7 blocks and one has 8.
That's right.
This aisle, this doesn't make sense.
so try that again.
I just don't get it.
You're just learning it. It's not going to make sense the first time you try something, Peyton Stainer. Quit with the attitude. All right. Guys, what did we say? It is a lot of guesstimating, but it's a lot of practice with this guesstimating so that you become better at that and you become more precise with your guesstimating. But you're exactly right, Chris. All right, what did I tell you about mean and median if it's roughly symmetric? They're about the same. So we're looking for our balance point, right, for our mean. If it's roughly symmetric, they are probably going to be very close, if not exact. So let's go ahead and just put our mean right about there. Okay. All right. Last one on this page, and then we're going to look at some other examples. Actually, we may move on and come back to that. Okay. Once again, we want to look for our median first.
What are you talking about?
Oh,
You should focus more.
So what do you think?
yeah, that sounds about
All right, we're looking at equal areas here, so we need to think about how much we're shading here.
I think that's too much shading. I think we gotta go more right.
Compared to what we are shading here.
He's right. Yeah, we definitely need to go right.
A little bit to the right, you think?
Just like in the middle.
Maybe I should do a little bit different color, maybe that'll help.
That other one's gonna be way taller than that.
Put it in the middle of that seven.
oops, wrong color, and I
You put it.
am going about where I was.
Both sides.
In the middle, throw that down. There you go.
So like imagine like this.
I can draw so straight.
You move two, or you need to move
Okay,
one.
so equal areas here, so is this shading about the same? Let me change colors, I don't know if that'll help or not. Is that the same in terms of what we have shaded from there
Oh, no.
to there? Is that about right?
Yeah, I think that's about right.
Okay. All right, I'm good with that median. All right, so there's our median. Sorry, let me change colors here.
Where's our fulcrum?
Oh, yeah.
When's this
So
test
this
due?
is our median.
When's this test?
All right, let's think about finding our mean. Now, the shape of this, we are skewed right. Remember what I told you about our mean? Our mean is going to be drawn towards where that skew is, okay? If we were to try to balance this right in the middle of the span of this, the spread of this, then we would say that the balance point would be right there. If it were totally symmetric, right? We kind of consider and we look kind of right along the middle. Obviously, that's not going to work because we've got a whole bunch more weight on this left-hand side as we do to the right. So it definitely has to get moved to the left, but we know based on the shape of this graph that our mean needs to be to the right of that. So it's going to have to be somewhere in between. I would make an estimate of about right there for this. Sorry?
Oh, never mind. Wait, but that was me.
Okay. So think about trying to balance. Part of it is you've got all of this you've got a span going out this direction. It actually probably is going to be a little bit farther to the left, but it definitely needs to be to the right of that. So I would
those
probably,
three blocks equal those 5 blocks on the other side? Basically.
No, it's the median, or it's the mean, it's the average.
you're thinking about or looking for the mean in a little bit different way than the median. Median is equal areas, mean, you have to consider the balance point. Okay? All right, this next page is just practice with that same thing, and if we have time at the end of class, we will get to that, but I want to move. Lots of practice if you notice. Okay? I'm sorry? Okay, so let's talk about what some graphs look like, different types of graphs now, and what the shape of those particular graphs is as well, okay? So if you notice, these first graphs are what's referred to as stem plots or stem and leaf plots. You may actually want to tilt your paper kind of to the side so that you can kind of look at this a little bit more clearer, because visually you can almost picture this. If you tilt your head to the right, you can almost picture this as if this is a graph and you've got your number line, right? So notice what it's telling us here. This is symmetric.
Oh.
This set of data is symmetric,
Oh, that's crazy.
right? Shift it. Notice that this next set is skewed right because it is trailing off to the right. And then this last set is skewed left because it's trailing off, the numbers trail off to the left.
That's a good point.
So visually looking at it as if it is a number line, I think can help with that. Okay? But that's an example of a stem and leaf plot with the different shapes. Guys, here's some dot plots. Let's go through and talk about these. What's the shape of this first dot plot there?
Skewed right. Oh, wait.
This
hold
one?
on. No, wait. Oh, it's just that part. Oh.
What do you think?
It's pretty symmetrical.
Yeah, I'd say roughly symmetric. What about this next set here?
Seems pretty symmetrical too.
Yeah, you could say, I have two things. I was checking to see what I put here because when I was looking at it, I was like, I could see a case for saying it's got a little bit of skew to the left. I definitely want to focus on the fact that this point out there is what we would definitely say is an outlier, right? So it has a high outlier. I would be okay with you saying it's got a little bit of skew to the left. I would also, another term to be familiar with is where think about when you guys have learned about the mode. Also, you've learned about mean, median, and mode, and you learned whenever that was. Remember, the mode is where the most numbers are, what the number is that is listed the most, right? So visually on a histogram or on a graph like this, what that's going to show is height. So that shows where the mode is, right? So in this case, there's actually it's bimodal. I was trying to write quickly, so it's messy and you can't read that. So bimodal would be another way of talking about or referring to this one. What about that next one? Skewed left or skewed right? Guess again.
That's left.
Your other right. Yeah, this is skewed left.
I don't understand. It's like all the way at the right.
And what would you say about this last one?
Oh, pretty middle.
Okay, it's roughly symmetric. Maybe has a possible outlier there, but roughly symmetric again. Symmetric, I'd be fine with you saying skewed right. I'd also be fine with you saying symmetric with a high outlier. Okay?
They're four different graphs. You don't like look at you don't look at like where they're placed on the square. You just look at like the actual dots in like that segment. There's four different levels.
But why are they placed in different areas?
It's just different sets of data. It's different graphs.
So you just put it wherever? No, like here. Like if I put this on this side, what's the difference?
What?
If I put these dots on this side, what's the difference?
Absolutely nothing. You would still say it's roughly symmetric. That's just kind of showing you, like, if you were comparing these on a number line, right? That first set of data is just a lower set of numbers. The third set of data here is higher numbers. So if we're looking, I don't know, as an example, this first set, these are probably numbers, if these are numbers like in the 40s, 50s, 60s, then these are numbers in the 120s, 130s, 140s.
Okay.
That's all. Okay, we're just looking at shape though. Don't worry about where they are kind of on the number line there. All right. On this last graph, if you notice, it's kind of showing you a comparison between, here's a set of data, right? Here's a set of data, and they're showing you or representing the data using a dot plot, using a histogram, and then as a box and whisker plot or a box plot. So I want you to think about or realize something here. Notice part of the issue is the way that a histogram is drawn, you cannot necessarily see outliers as well as you don't see quite as much detail sometimes with a histogram as you do with a dot plot or a stem plot or a box and whisker plot. So the idea here is to kind of focus on and help you realize in this box and whisker plot or this box plot and this dot plot, you can kind of see a little bit more clearly, okay, there is a distinct outlier, a high outlier. You don't necessarily notice that with the histogram. So histograms can be good kind of overall, kind of in general. It doesn't necessarily show as much detail. All right? So something to consider, think about there. All right. Grab your calculators. And
Our package so yeah, we don't got that.
okay. Oh, I've got the different numbers there.
Talking about Barry Bonds.
I've got the different numbers there. That's fine. We'll look at that. Sorry. Okay.
Mr. Bond.
All right. So did I? All right. I will have to get you that page. That's fine. We'll move on. Shoot. Okay. Okay, we'll talk about the mean and all of that in a little bit. We'll talk about that later. Remember what we said, to find the median, we are placing those numbers in order first. If they were not already put in order for you, you're welcome, I put them in order for you. So in order to find the median, we are finding the middle number. And remember what Ethan asked, if there are two middle numbers, we're going to find the average of the two, right? So what is the median for this first set of data? 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So that 4 is the median for that set of data, right? And what is the median for that second set of data? Yeah, we have two middle numbers, and so then we are finding the average of those two. So we get that 7.5. So that's exactly what Hunter was explaining to Ethan earlier, right? Okay. So we have the 5-number summary we are going to use to represent certain types of data. We use the median along with the 5-number summary, so make a note about that. Okay, so we use 5-number summary to represent our spread, and our center in that case would be our median. And we're going to talk about when we use each of those early next week, okay? We'll get back to that. So we're going to look at the median. We're going to learn how to find the 5-number summary, and then to represent that 5-number summary, we draw a box plot. So that's what this is going to help us with, is that whole process of creating a box plot, aka box and whisker plot. Okay? All right. So in order to find the 5-number summary, the first thing that we will do is find the median for this set of data. And then if you notice, it says we find the median for the lower half of the data, and that's what's referred to as quartile 1. And then we find the median for the upper half of the data, and that's what's referred to as quartile 3. So the 5-number summary is going to consist of, Ryan, the minimum, quartile 1, the median, quartile 3, and the max. Yes, we also use it to kind of, like when we're dealing with data, to kind of just break up the data into different parts. Guys, let's think about this. If we're breaking it into quartiles, what does that imply about the data? If we're finding the halfway point, and then we're finding the halfway point for the lower half and halfway point for the middle half, what percent is in each little?
25.
Yeah, we're breaking this into quarters, right? Hence the idea of the quartiles. I'm sorry? Q3 minus Q1 is our interquartile range, and we're going to talk about that. Yes. Yep. Okay. So we're comparing baseball home runs here. Anyone know I have that 73 in parentheses?
No, that boy was roided up.
Yep, he was.
Very bomb.
He was. So we're not going to count that one.
No, you can't count
One of those, huh?
Can't count those.
We're not going to count that.
That's an outlier.
Everyone-
That would definitely be an outlier, you're right. So we're just not even going to count that one. All right. So we're going to look at just this set. We're going to focus on one set first. So we're going to look at this set for Babe Ruth. If we are going to find the median, Ryan and Ethan, you still haven't figured out that when I called your name, it was to gently tell you to be quiet. So now obviously you need the full out call out. Stop. Okay. We're finding the median first, so we're looking for the middle of this set of data, and I have them in order to help you with that. And so the median for Babe Ruth's data is 46. Okay? Then we need to find the median for the lower half of the data. We need to find the median for the upper half of the data. And so I've that's kind of why I put the list the way I did, so that you could focus your attention strictly on, here's the lower half. We are not gonna include that 46 that was the median. We are not gonna include that. We are just looking at the numbers from 22 up to that first 46. So we are looking for the middle there, and it looks like it's at 35. And here for this upper half of the data, the median, or quartile 3, the median of that data, which would be quartile 3, would be that 54. Okay? All right. So I want to make a list of what the 5-number summary is for Babe Ruth's data. So the minimum value is what?
22.
22. Quartile 1 is
35.
35. Median is 46. Quartile 3 is 54. And the max is 60. All right, now let's do similar process for Barry Bonds. Okay, so our median, actually, I think, is those two numbers. That's our median. And then we are looking for the median of the lower half. We are not going to include either of those 34s when we are finding the quartile 1, the median for the lower half. So what does that end up being? I'm not sure. I don't remember. It's the first 25 here, and it's the 42 here. Okay, so our minimum for Barry Bonds is 16. Quartile 1 is 25. Median is 34. Quartile 3 is 42. And max is 49. All right. Draw we're gonna draw box and whisker plots for both of these so that we can kind of compare them. So draw a line down the middle of your page, kind of label it as you see this. Actual process of creating a box plot or a box and whisker plot is that I'm gonna look at numbers here so I can, sorry. Okay, we basically we need to use our number line kind of as a scale, but then we just want to put points to mark where each of these particular values is. So we've got a point over here at 22, and then try to stay consistent right above that. I've got another point at 35, and then another one at 46. And then 54, and then 60. So I have those 5 points there, okay? The middle point we know is our median, and we're gonna draw basically a line across there to show our middle. We also, a box and whisker plot, we create the box first, just to kind of help us with drawing or creating that. So draw a box there, and then from the box out to each our minimum and our maximum value. Okay.
Quarter 3 to quarter 1 for the box.
So the box, yes, the box represents from quartile 1 to quartile 3. Great observation, Christian. Quartile 1 to quartile 3. It's also, the other way of thinking about that is it's the middle 50%. Right? Think about what Hunter was saying and what I was trying to get you to think about, guys. 25, yikes. This is 25, well, come on. This is 25%. This is 25% of the data. 25% of the data lies here. 25% of the data lies there, right? And in those intervals. So the middle 50% is represented by this box. You are right. All right, let's draw the box plot for Barry Bonds, and then we'll make some comparisons here. Okay, so 16, oops, I want to change colors here. 16, 25, I need to make this a little bigger to help me with this. 34, 42, and 49. And draw your box. The middle of that box, well, where that line is for the box, that's your median, right? Okay, so if you felt like you wanted or should include that 73 in there, I don't particularly feel like we should. But you could make a note, there's this outlier at 73, but like I said, that, in my opinion, that should not be included. So I'm not including it. I want to kind of erase this. All right, I want some observations. I want to hear some observations from you all about, there we go. Make some comparisons between those two sets of data, between Babe Ruth's home runs and Barry Bonds's. What do you think?
It's higher.
What now?
It's higher.
What's higher? Go quickly. Okay. Be more specific, Peyton.
It's also longer.
It's a wider range.
Okay, so higher means that he's got larger numbers of home runs. Let's give context and explain. It's longer. What would that really mean? That means where the spread or the range of values is greater as well. What about making some comparisons from like where are the medians? How do those compare? How does the median compare? Like, let's look at, what do we know about the median for Babe Ruth compared to quartile 3 for Barry Bonds?
It's a lot higher.
Okay, so even the median, which means the middle, right, for Babe Ruth is higher than quartile 3 for Barry Bonds, right? How can we compare, let's compare this, just the highest point, the maximum value for Barry Bonds compared to Babe Ruth. Yeah, it's less than quartile 3, right? So think about what that means. That means more than 25% of the values in Babe Ruth's set of data is greater than all of the values for Barry Bonds, right?
Which is better.
So the extension of this would be, once I ask you guys to create graphs like this, if I'm asking you to compare them, is that then I'm going to ask you to make some observations like that, and then I would possibly ask you to state, who do you think the greatest of all time is based on this information between these two? We're gonna compare. If you look at the calculator stuff, we're about to compare two others. So we'll get to that though. Okay. All right.